Okay, we're going to take a look at the air conditioning with electric heat simulator board today, and we're going to try to make several videos, small videos on each individual component, electrical component of the system to start with, and just be able to identify each component and what their functionality is in the system. We're going to start with the actual power coming in here. First of all, we have a 120 volt power cord here, and but in all reality, an electric heat system with air conditioning runs off of single phase 240 or 208 voltage. It'd be a 208 voltage if it was a commercial application, but we're going to mainly be discussing residential. And so we're going to simulate this board as 240 volts. We have two double pole 60 amp breakers right here at our power source, and we have our black wire here coming in from the power, going through our fuse protection just for safety reasons on this simulator, and we're coming into line 1 on this breaker, and line 1 jumps over here and also feeds this breaker. And so then you have line 2 coming into this side of this disconnect breaker and also feeding the other side of line 2 here. And we'll get into the wiring aspect of it later and be looking at the schematics on how that we wire the system using a schematic drawing. But first of all, you got to be able to identify the components of the system and understand their functionality. And like I said, there's your spade connectors on this side where you'll be taking your power from line 1 and line 2. And so that's power in, 240 volts. That's two hot legs of power, line 1 and line 2. And the first thing and component I'm going to try to talk about in the system, I'm going to try to go in the sequence as they actually are in the system. You have power in at 240, as we said, and then you come over here to your control voltage transformer, where we step it down to 24 volts for our control voltage. The reason we do that, we can actually use a lot smaller wires going to our thermostat that we're going to talk about here in a minute. But it's also a safety issue with the homeowner. Will be actually operating the thermostat, could possibly open it up and could get electrocuted, so we want to step down to the 24 volts for those reasons. And but you have a primary side of your transformer and a secondary side of your transformer. This is a multi-tap transformer here, and that's why you have all the different wires. We can actually use this transformer for a 120 volt application, a 208 application, or a 240 volt application on the primary side. And whichever voltage we use, it will step down to the 24 volt side. You'll have a 24 volt hot on the yellow wire and a 24 volt common on your blue wire here coming out, which we have a green ground there because we always want to ground the common side of the transformer to the chassis. On some applications you don't have to, and you won't see it because the actual mounting bracket of the transformer grounds it. But on this particular transformer, it does have to be grounded. The white wire here, or actually the black wire, is our common leg of power. So one leg of power will have to come in from the primary 240 volts to the black wire, regardless of what voltage you decide to use. Since we're using 240 volts, we're going to hook one leg of power into the black common wire, and it says that right here on the schematic. And a lot of times we would think the white wire would be the common, and so don't get that. Always read your schematics if you can, and what the control says. But also, if you're going to be using 240 volts, you're going to be using your orange wire. So we won't be, on this application, we'll have the common wire, one leg of power of 240. The other leg of 240 will go to the orange wire for our primary voltage. Since we're not going to be using 120 volts, that's where your 120 volt leg would have went, and this would have been your other leg for 208. We'll want to actually shut those off for that application. And this is I'm sitting here, flies flying around my camera here, and I can't even think straight. Now, again, we're simulating the 240 volts, so that's why you see the connector on the 120 volt leg. So we're actually going to be using the common leg for the 120 hot, and the neutral, and the white wire will bear 120 volt hot, since this is in all reality 120 volts. But just remember, we're simulating it as 240 volts. So in a real system, you would be hooking up the orange wire with the black wire. The other wires have to be capped off because they will feed electricity, and it will short out on the case or get you. So let's pause just for a minute. Okay, we're back. Now let's look at the primary voltage is hooked up, simulating 240, but we're hooking up to 120. That's going to give us 200. Oh, I'm sorry, that's not going to give us 200. That's going to give us 24 volts on the secondary side. 24 volt hot with a fuse. Always put an inline fuse with your 24 volt hot. That'll save your transformer in case of a short. It's a lot cheaper to replace the fuse and replace the complete transformer. And then we'll have the common side of the 24 volts that goes to each individual 24 volt coil that we'll be talking about later, and it'll also be grounded to the chassis. And we're going to talk a little bit about the transformer also. It's rated again in the voltage of the primary side and the secondary side, but it's also rated in 40, or in VA, which is volt times amps, which is watts. Same thing. If you hear VA, you might hear it called watts, 40 watts. But this particular transformer is a 40 VA. And if you want to know how many amps that you can actually pull on this transformer, then you take your VA divided by your secondary voltage, which in a 40 VA would be 1.66. That means we can only draw 1.66 amps on the secondary side of this transformer, which is plenty for just a standard residential system with the components that we have, because you're going to be operating in the heating mode. I don't want to chase no rabbit at this time, but again, let me recap on this transformer. It is the 24 volt step down transformer to 240 volt, 208 or 120 multi-tap on the primary, and we're going to step down to 24 volts to run all of our control voltage. It is rated in VA, and this is a 40 VA transformer. And again, to check how many amps you can pull on the secondary side, you will take the 40 VA and divide it by 24 volt secondary, which will be 1.66 amps maximum. We usually use about a 3 amp fuse. That'll still protect the transformer. It'll blow the fuse before it burns the transformer.